Hi students, today we are going to discuss total 30 questions from the chapter P block elements, and the type of question that we are going to discuss is MCQs and assertion reasoning type. So first start with question number 1. Among the following, which one is a wrong statement? A. pH5 and BiCl5 do not exist. B. P-pi D-pi bonds are present in SO2. C. SeF4 and CH4 have same shape. D. ICl3 has bent geometry. So first start with A. Okay, pH5 and BiCl5 do not exist. The statement is true. So this two molecule will not exist. Okay. Now second is your P-pi D-pi bonds are present in SO2. Okay, so this is the structure for SO. So there is a multiple bond, right? And that this multiple bond is because of your P-pi D-pi bond between your O and S. So again statement B is true. Then C, SeF4 and CH4 have same shape. So if you see the structure SeF4, okay, so SeF4 it will have the hybridization state sp3d, okay, d. So it will have the shape, right? Then Se, so F, so 1 2 3 4, and there will be a lone pair. Okay, so this is your shape for SeF4, and for CH4 we know the hybridization is sp3, right? So it will have a regular tetrahedron shape. Okay, so both don't have the same shape, right? So option C is the incorrect statement, wrong statement. So last D, so ICl3 has been geometry. Now in ICl3, okay, the hybridization state is again sp3d. So then this is I, right? Now because of presence of two lone pair, it will have little bent. Okay, so Cl, Cl. So we call that bent T shape. So again option this D is correct statement. Now next question number 2, which is strongest acid in the following? HClO4, H2S2O3, H2SO4, HClO3. So you need to check is the oxidation number. So oxidation number here is maximum +7. So here is +6. यहाँ कति छ +5, then +4. Okay, and Cl again, right? It is your halogen compound. Now so A, where the oxidation number is maximum of your Cl, so ClO4 is the strongest acid. Moving to the question number 3, the correct order of oxidizing power. So all these are oxoacids of halogen. Okay, so option A, HClO4 maximum, then HClO3, then HClO2, HClO. So this is in decreasing order. Okay, from ClO4 to HClO. Then HClO will have the highest, then HClO4 will be the lowest, option B. CMA, there is random, right? HClO3, then HClO4, then HClO2, HClO, then option D, HClO2, HOCl, HClO3, HClO4. Now again, so here you need to check the oxidation number state. If you compare the oxidation number state of HClO4, okay, its oxidation number here is 7. Then HClO3, the oxidation numbers oxidation state here is 6 + 5. Then HClO2 +3, and HClO, here is the oxidation number +1. Okay, now so oxidizing power here depends on the oxidation number. So oxidation number, when it increases your oxidizing, okay, power, it decreases. So that means the one which have low oxidation number will be more oxidizing in nature compared to the one with the highest oxidation number. So which one? This one is having the highest, right? So this one will have the least oxidizing power, then this one, this one, this one. So HClO will have the highest oxidizing power. So which option is the correct one? Option B. Okay, where HClO is having highest oxidizing power and HClO4 is having the least oxidizing power. So among the following, which is strongest oxidizing agent? Okay, so bromine, chlorine. So all halogens are strongly oxidizing in nature, right? Because after gaining one electron, so they will acquire the noble gas configuration. So they have very high tendency to accept electron, or they have very high electron gain enthalpy. Now among these four, okay, one is having the strongest oxidizing agent, and that is fluorine. So fluorine is strongest oxidizing in nature. Why? Because of your more negative, because of low bond dissociation enthalpy. Okay, then ध्यान देखिए number 2, okay, low electron gain enthalpy, less negative electron gain enthalpy compared to that of your chlorine. Okay, then third one is it will have high hydration enthalpy. Okay, because of this three reason, okay, this fluorine is the strongest oxidizing in nature. Now next question is, when chlorine reacts with hot and concentrated sodium hydroxide, the oxidation number of chlorine changes from 0 to +1 and 0 to +5, 0 to -1 and 0 to +5, 0 to -1 and 0 to +3, 0 to +1 and 0 to -3. So for this we need is the correct equation for the reaction Cl2 and concentrated NaOH. So when Cl2 reacts with hot and concentrated NaOH. Okay. Now what are the products? So it give NaCl, sodium chlorate, NaClO3 and water as a byproduct. Okay, sir. Now let us check the oxidation number here. So this is chlorine and it have oxidation number 0. Okay, in this case, so +1 and this one is having -1 oxidation state. NaClO3. So if you find out the oxidation number, just a sodium co +1 ho, you need the oxidation number of Cl. So let this be X by +3 oxygen and एउटा को कति हो -2 equal to 0. So X तिम्रो आउँछ, so +1 and -6 कति भयो -5. So when this go other side of equal to, so +5. So the oxidation number here is +5. So what is the change in the oxidation number of chlorine? 0 to -1, okay, and 0 to +5. So this reaction is what called disproportionation. Okay, why? Because the same is getting oxidized, the same is getting reduced. So the change is from -1, 0 to -1 and 0 to +5. So which is the correct option? Option number B, 0 to -1 and 0 to +5. Now moving to the next question. Acidity of diprotic acid in aqueous solution increases in the order. Now, so all these are hydride of group 16 element, right? So every time, so on moving down the group, what happen is bond length increases because of increase in the atomic size of the central atom, then bond strength decreases. So with the decrease in the bond strength, the S with which hydrogen ion remove will become easier, right? So it means, so on moving down the group, the release of hydrogen ion become easier and easier because of low bond dissociation enthalpy. So that means your acidic strength will increase down the group. Okay, now sulfur, selenium, tellurium. So tellurium is at the bottom, so in this 3 element, right? So the correct option is option A. So H2S, H2Se and H2Te. Next question is chlorine reacts with excess ammonia, okay, to form. So when chlorine reacts with ammonia, okay, so when ammonia is in excess, so we'll get ammonium chloride and nitrogen. Balanced equation, okay. So ammonium chloride and dinitrogen. So what are the options? So ammonium chloride, nitrogen and HCl, dinitrogen and ammonium chloride, and nitrogen trichloride and HCl. So which is the correct option? Option C. So whenever chlorine is react with excess of ammonia, we'll get ammonium chloride and dinitrogen. And if your chlorine is in excess, okay, then the product, you will get different products. So you will get NCl3, that is ammonium trichloride and hydrochloric acid, if your chlorine is in excess. But question is your ammonia is in excess, so correct option is option C, ammonium chloride and dinitrogen. Next question, which of the following statement is incorrect? ONF is isoelectronic with NO2 minus. OF2 is an oxide of fluorine. C. Cl2O7 is an anhydride of perchloric acid. D. O3 molecule is bent. So let us check all the statement whether this is true or incorrect. So first we'll start with O and F. Okay, now what is the atomic number of oxygen? It is 8, for nitrogen 7, and for fluorine it is 9, right? So what is the total? 16 plus 8, 24, right? And next is your NO2 minus. What is the atomic number of nitrogen? It is 7, plus oxygen 2 are there, so 16 plus 1. So again 8 plus 16, 24. So the two contain same number of electrons. So these two are isoelectronic. So A is correct statement. Now next B. OF2 is an oxide of fluorine. OF2. So this is incorrect statement. Why? Because so oxygen and fluorine. So among the two, fluorine is more electronegative, right? So instead of naming the compound oxide of fluorine, rather these are called oxygen, fluoride of oxygen. So this is your fluoride. So B statement is incorrect. Okay, so we'll move to the C. Cl2O7 is an anhydride of perchloric acid. Okay, and this is your true statement. Okay, now D. O3 is bent ozone molecule, right? So you know the structure very well, right? The resonating structure. So this have the bent structure. So again D is also correct statement. So the only incorrect statement is option B. OF2 is an oxide of fluorine. Now next question, which of the following reactions is an example of redox reaction? A, B, C, D is given. So what is redox reaction? So where your oxidation reduction takes place simultaneously, right? So let us check whether the reaction is redox or not. So for that we should know the oxidation number, whether there is change in the oxidation number or not. Okay, the oxidation number of xenon in first option is +4 and it is changing to +6, right? So that means there is change in the oxidation number. So oxidation number increasing means it is getting oxidized. Then here the oxidation number +1 to 0. So this is your reduction, right? Decrease in oxidation number, so reduction. So this is your redox reaction. Redox reaction. Now check rest. So oxidation number +2 xenon, and here again +2, no change in oxidation number. So this is not a redox reaction. +6, +6, +6, +6. So in these three options there is no change in oxidation number, so it's not a redox reaction. So only one A is the correct option. It's an example of redox reaction, because there is change in oxidation number of xenon from +4 to plus 6. Next question, on addition of concentrated sulfuric acid to chloride salt, okay, colorless fumes are evolved, but in case of iodide salt, violet flames comes out. This is because sulfuric acid reduces Hi to I2, Hi gets oxidized to I2, Hi is a violet color, Hi changes to HiO3. Now, so when your concentrated H2SO4 is treated with your salt chloride, okay, so chloride salt, then that time we will get is colorless gas, and that is because of your formation of HCl. Now, so whenever this sulfuric acid, okay, so it's reacted with salt of bromide or salt of iodide, okay, salt of Br or I, then what happen is it releases either HBr or Hi. Okay, now these two are strong reducing agent. Okay, so these are strong reducing agent, and self will get oxidized to I2. Now this I2, okay, is coming out, and because of this you are getting the violet flame. So the correct option is option C, Hi get oxidized to I2. Again, your salt of Br and I, okay, so iodide and your bromide give acid Hi, and these are strong reducing agents, so because of that it will get oxidized to give iodine violet vapor. Now next question, which of the following pairs of ions are isoelectronic isostructural, so having same number of electron and same structure? CO3. Now, so to check the number of electron, right, so add its atomic number with the charge also. So 6 plus 24 plus negative means you have to add 2 electron, right, so 32 32. And if you check the hybridization state, okay, so both will have the hybridization sp2, so that means both will have the structure, same structure, let's say, okay. So option A is the correct answer. Now, if you compare B, this is chlorine, okay, and carbon. Now, see, both have same number of oxygen. So, if you want to check whether they are isoelectronic or not, so you can check like chlorine. So, it belong to what? It have atomic number 17, right? So 17 and this have 6, so there is vast difference between the two, so these two will not have the same number of electron. So same here, so this sulfur and nitrogen, so sulfur 16 and nitrogen 7, they have same number of oxygen. Again this S and SO3 2 minus and NO3 minus will not be isoelectronic, and again this is 17 and okay, so let's check this one. So this is your 17 D, okay, 17 plus 24, okay, and option D, okay, both contain same number of electron 42 42, and both have the same hybridization state sp3 and both have the same structure, okay, pyramidal. So again option D is correct option, okay. So A and D are the pairs of ion which are isoelectronic and isostructural. So sometimes you will get the question that multiple choice question with only one correct answer and multiple questions with one or more correct answer. So that time you need to check all the options, but for multiple choice question with only one correct answer, that time once you get the correct answer, okay, no need to check the rest to in order to save your time. Now next question is affinity of hydrogen for hydrogen decreases in the group from fluorine to iodine to the way है ना. So which of the halogen acid will have highest bond dissociation enthalpy? So on moving down the group, the affinity decreases and also the size increases or bond length increases, right? Because of that bond dissociation enthalpy decreases. So the one which have the highest bond dissociation enthalpy is your HF. Now next question, hot concentrated sulfuric acid act as moderately strong oxidizing agent, right? So it oxidizes both metal non-metal, right? So which one of the following element is oxidized by concentrated sulfuric acid into two gaseous product? Okay, copper, sulfur, carbon, zinc. Whenever your copper reacts with this sulfuric acid, so it will form, okay, copper sulfate and sulfur dioxide. So your sulfur will oxidize to sulfur dioxide, water. Carbon will oxidize to carbon dioxide, sulfur dioxide and water, and zinc. Okay, so it will form sulfur dioxide, which it further oxidize to H2S or sulfur. Okay, zinc act as a strong reducing agent. Now, so if you compare the look at the product, okay, so carbon dioxide is a gas, sulfur dioxide is a gas. So concentrated sulfuric acid, okay, so in which case you will get two gaseous product when your concentrated sulfuric acid is treated or reacted with carbon. So option C is the correct answer. H2S is more acidic than water because oxygen is more electronegative than sulfur. Atomic number of sulfur is higher than oxygen. S bond dissociation is less as compared to HO, and HO bond dissociation is less than compared to HS bond. Okay, now we know that sulfur, it's below oxygen, it have more atomic size, and because of that the bond length is longer here, right? And because of long bond length, so it will have low bond dissociation enthalpy. So HS bond dissociation energy is less as compared to HO, because of which your hydrogen is easily released. The ace with which hydrogen release in H2S is much higher than that in H2O. So H2S is more acidic than H2O. So that means option C is the correct answer. Now next is the boiling point of hydride of group 16 are in the order. Okay. Now boiling point, what happened is your boiling point of water is maximum, right? Why maximum? Because in water, so there is it form intermolecular hydrogen bond. Now, okay, and on moving down the group, what happen is it will have very exceptionally high boiling point. But on moving down the group, what happen is your boiling point will increases, okay, from sulfur H2S, then H2Se, then H2Te. So what would be the correct option? So H2O, then कसको छ next highest छ तिम्रो H2Te, the next highest छ H2Se, then छ तिम्रो H2S will have the least boiling point among the group. Okay, so which is the correct option? Option C, H2O, H2Te, H2Se, H2S. Okay, and why there is increase in the boiling point on moving down the group? Because of increase in the magnitude of van der Waals force of attraction. Now when chlorine, okay, reacts with cold and now dilute NaOH. Now what would be the product? So if you know the product, then you easily able to answer or choose the correct option from these four options. Okay, answer from these four options. So timro, whenever so chlorine is reacted with dilute, then hamro ta euta pauncha sodium chloride, okay, will get salt, and another salt is your sodium hypochlorite. Sodium hypochlorite, NaOCl. Concentrated ma sodium chlorate pauncha, NaClO3, that you need to memorize. Okay, so H2O. Now so here, so when it dissociate, it will give Cl minus, and now when it dissociate, Na will dissociate, okay, release, so you will get is ClO minus. So among the two, so these are the two ions which you will get when your chlorine reacts with cold and dilute sodium hydroxide. But which option is correct? Cl minus and ClO minus. So option A is the correct answer. Where Cl minus and ClO3 minus you will get when chlorine reacts with concentrated hot and AOH. Next question. The formation of this oxygen compound PTF minus 6 is the basis for the formation of first xenon compound, right? So first xenon compound is your XePTF6. Now what is the reason? Oxygen xenon have different size? Wrong. So both oxygen and xenon are gaseous. Okay, so gases, though they are gases, but this is not the reason for the formation of first xenon compound. So comparable electronegativity. So oxygen is most electronegative, right? Then O2 and Xe have comparable first ionization enthalpy. So option D is the correct option. So comparable size, because of that, so they will have comparable first ionization enthalpies. So for 17, D is the correct option. Partial hydrolysis of XeF4 gives. So whenever this xenon hexafluoride, okay, this tetrafluoride. So when we do the partial hydrolysis, then we'll get is XeOF2 plus 2HF. So among this, okay, which is the correct option? A, B, C, D. A, B is the correct option. So XeOF2 is the product when you will get when you do the partial hydrolysis of XeF4. Next question. So helium is preferred to used in balloons instead of hydrogen because it is incombustible, lighter than hydrogen, more abundant than hydrogen, non-polarizable. And the answer is, the most appropriate answer for this question is incombustible. So they are inflammable, so non-flammable, okay, because of this. So helium is preferred to be used in balloons instead of hydrogen, which is highly flammable. Next, okay, which of the following on heating produces NO2? Your sodium nitrate, silver nitrate, ammonium nitrate and ammonium nitrite. Let us check the reaction. Sodium nitrate, silver nitrate, ammonium nitrate and ammonium nitrite, and the correct option is your silver nitrate. So silver nitrate on heating produces NO2, nitrogen dioxide. Next question is, which of the following oxy acid contain both pH and PP bond simultaneously? So you need to draw the structure to answer this question. Now these are the structure for H4P2O5. Okay, so it contain your POP bond, PH bond and POH bond. Okay, no PP bond. So your case ma though PH bond cha, there is no PP bond. PP bond chaina. So yeah, okay. So there is P double bonded O bond. Okay, POP bond cha. त्यहाँदेखि POH bond cha. So there is no PH, no PP bond. Then in this case, what you can see is, okay, यता के छ तिम्रो P double O bond cha, then PP bond cha, okay, PP bond is there and POH bond is there, but there is no PH bond. भयो यो छैन भनेपछि, so in this ABCD, ABC ma, so यो तीनटामा there is no PH bond, there is no PP bond simultaneously, so the answer is D, none. So in which process does the nitrogen undergo oxidation? So again check the oxidation number. If it is decreasing, then oxidation number. So what is 0 oxidation number? Then NH3. So this is -3. Okay, your case ma kati bhayo? What is the oxidation number? So this is 6, right? So uta jandakheri kati huncha? +5. The change of oxidation number here +5, there is no change. Okay, here also there is no change, but here +3 to +5. So your oxidation number increase hundesa. So this is oxidation, right? And here the oxidation number is decreasing from 0 to -3. So this is your reduction. So what is the question? So where your nitrogen undergoes oxidation? So option is D, where your oxidation number is increasing. Next question cha, which is the correct statement for the given acid? Phosphonic acid, okay, is monoprotic while phosphonic acid is diprotic. Phosphonic acid is diprotic while phosphonic acid is a monoprotic. Both are triprotic, both are diprotic. So for this again you need to draw the structure. Okay, phosphonic acid, okay, phosphonic acid have the structure H3PO2 formula, and phosphonic acid, okay, it have the formula H3PO3. Draw the structure. So both have the tetrahedral structure. Okay, now the oxygen, then hydrogen. Now these are the structure, okay, of phosphenic and phosphonic. Now phosphenic you can see is 1 OH. Now this hydrogen is ionizable. Only this hydrogen is ionizable, not this one. So it contains only 1 OH. So this is monoprotic. monoprotic. Why? Because it releases only one H plus ion, one proton in this case. So there is two ionizable H plus ion, right? So this is your diprotic as it releases two H plus ion. So which is the correct option? This is monoprotic. Your phosphonic is diprotic. So option A is the correct answer. Phosphonic acid monoprotic, phosphonic acid diprotic. Now next is, in a cyclotrimetphosphoric acid molecule, how many single and double bonds are present? Again, draw the structure. Okay, what is the formula for cyclotrimetphosphoric acid? It is your H3P3O9 or HPO3 whole 3. Okay, this is a cyclic one. Now how to draw it is a 6-membered cyclic structure with phosphorus, then oxygen, okay, then phosphorus, oxygen, phosphorus, oxygen. Now your phosphorus tetravalent, so it will have, okay, 4 bond, right, 4 bond. So then oxygen kotira bha 9 ora cha total, right? So tinta use bha now 4 5 6 7 8 9. Okay, now hydrogen kati cha tinta, so distribute equally 1 2 and 3. Now the one which is yours only oxygen will form double bond with phosphorus. Okay, now question is how many double bond and single bond are present? So double bond kati ora cha 1 2 and 3. So 3 double bond, okay, and single bond 1 2 3 4 1 2 3 4 5 6, okay, 7 8 9, and there is single bond between oxygen and hydrogen as well, right, 9, then 10 11 12. So how many single bond are there? 12 single bond are there. So 3 double bond, 12 single bond. So which is the correct option? A no, B 6 6 no, C 3 double bond, 12 single bond. So option C is the correct answer. Now next is assertion reasoning type question. Okay, so from 26 to 30. Now 5 option will be given to you. Now from them you need to choose the correct option. One is your both assertion reason correct, reason, okay, and is the correct explanation of the assertion. Okay, sir. B ma both assertion and reason are correct, but reason is not the correct explanation of your assertion. C ma assertion correct, reason incorrect. D ma assertion incorrect, then but reason correct. And if your both assertion and reason are incorrect, you need to choose option E. So we'll start with question number 26. HI cannot be prepared by the reaction of Ki with concentrated H2SO4. This statement is true. Okay, HI has lowest X bond strength among halogen acid. Now if you see the reason, HI will have the lowest bond dissociation enthalpy. Yes, because it is at below, right, almost at the bottom of the periodic table. So for that reason it will have the low bond dissociation enthalpy. So this statement is again true, but reason is not the correct option for your this one Matthew assertion. Why? Because on moving down the group, what happen is your affinity toward hydrogen become lesser and lesser. Now if you see Ki, okay, so the two this potassium will high affinity towards I. So for that reason, so it is where here the affinity between the two is not that much strong. So for that reason it is not easy or prepared by this reaction. True, this is true, but reason is not correct. So which is the correct option? Both are correct, but not the correct explanation of assertion. So B is the correct option for this question. Now next is assertion. Both rhombic and monoclinic sulfur exist as S8. Okay, right? Monoclinic, rhombic, yellow color. So S8, but oxygen exists as S2, right? So reason. Oxygen form p-pi multiple bond due to small size and bond length, but p-pi bonding is not possible in sulfur. Okay, so your oxygen exists as diatomic molecule. Very good. Why? Because yes, it's correct, because your p pi oxygen can form, right? It has unique tendency to form p pi multiple bond. So त्यसले गर्दाखेरि चाहिँ, okay, and also one more reason is there, like sulfur co catenation property is higher than that of oxygen, so it exists as it. So for this, okay, I can say the option A is the correct one, because the reason is also correct. Oxygen exists as O2 as because it have the tendency to form p pi. Oxygen, sulfur have very less tendency to form p pi. Now next is assertion. NaCl reacts with concentrated sulfuric acid to give colorless fumes with pungent smell, but on adding MnO the fumes become greenish yellow. Reason: MnO oxidizes HCl to chlorine gas, which is greenish yellow. Yes, so when you react H2SO4 and NaCl, you will get colorless gas. Yes, that is because of release of HCl. But when you add MnO2, okay, what happen is, yes, so this one HCl will now oxidize to chlorine, and chlorine, so it have the greenish yellow color. So that means your assertion is correct, reason is correct, and both this reason is the correct explanation for the assertion. For 28 also the correct option is A. Your assertion: nitrogen is less reactive than P4. Okay, nitrogen has more electron gain enthalpy than phosphorus. Okay, so this N2 is less reactive. This is true statement. Okay, nitrogen has more electron gain enthalpy than phosphorus. This is incorrect option. So this is incorrect statement, as because so the period 2 element, okay, so they have less electron gain enthalpy compared to the next member, as because they have very compact size, because of which they will they will experience inter-electronic repulsion, which will make their electron gain enthalpy less negative. So that means your this reason is incorrect. Okay, so your assertion correct, reason incorrect. So which is the correct option? C is the correct option for 29. Now 30 macha, SF6 cannot be hydrolyzed but SF4. So this is true. SF6 is this is kinetically inert, right? It cannot be hydrolyzed, where SF can. So the reason given is like 6 F atoms in SF6 prevent the attack of water. Very true. So if you draw the structure, octahedral it will have, right? And 6 fluorine atom is sterically protecting it from the attack of water molecule. So the reason is correct here. Whereas SF4, when you see SF4, this is the structure for SF4 where your sulfur is not sterically protected. So this can then easily be hydrolyzed by water or attacked by the water. So for this statement is correct, your assertion correct, and reason correct, and reason is the correct explanation of assertion. Again for this question, okay, the correct answer is A. So hope you have all enjoyed the session. Thank you all.